Okay, so I want to look at architecture here, and specifically I want to look at quite real-world architecture. We've had a lot of talks today about very interesting shiny toys, which are very interesting and very cool, but are difficult to immediately start putting into practice and getting direct value out of. It's difficult to see exactly how you put that into use. And at the same time, both here and every other conference in the world, there's a lot of people talking about the nice theories behind this kind of stuff, the nice ways to think about microservices, but not so much about what this architecture actually looks like, and kind of bring you towards what you need to think about to actually do this in practice yourself. So what I want to do today is take a look at some actual microservice architecture that we've built, look at how that works and how that solves our problems, other approaches we could have taken and how those don't work, and give you a bit more of a real-world vision of this stuff. We'll start with a little bit of context. I work for a company called Softwire. We make software for other people. We've got offices in London and here in Bristol, and we build bespoke projects for people like the BBC, or like Cisco, or all sorts of others, or you, if you're interested in that, so do come talk to me later. We do a lot of architecture design as part of this process, both because we're continually building new projects for people, but also because we're pitching new projects to people. We have to propose some kind of idea of what we're going to build in advance. And we spend a lot of time thinking about these kind of problems and these kind of approaches. And more we've been seeing over many years, service-oriented architecture picking up, push more and more into better modular approaches, and now into microservices, and the kind of value we get out of these. This has worked out very well for us in quite a few projects, and more we're moving towards quite microservice-focused approaches, and we're finding a lot of quite concrete value and a bunch of exciting, interesting new challenges. The actual project I want to talk about is BBC Newsbeat. Does anybody know? Has anybody ever heard of BBC Newsbeat? Yeah, a few nods sprinkled around. It's the news for Radio 1. It's a collaboration between the BBC News team and the Radio 1 team. It's trying to be BBC News for a slightly younger audience. So we're pitching towards 16 to 24-year-olds here, really. Content-wise, it's a bit more pop culture, a bit more music and entertainment sort of stuff, but still trying to bring in the kind of BBC dedication to actually hard-hitting, neutral, well-informed news, and trying to bring that back in a slightly more bite-sized, accessible approach. There's lots of interesting design stuff behind this that I'm not really going to talk about, but the key things that I want to think about here are that we're really trying to compete with social media to make this stuff work. The audience we're looking at get their news mostly from Facebook and Twitter and so on. The other things that are taking their attention are stuff like BuzzFeed. We're in a relatively difficult niche that is really characterized by people writing content, getting out really, really quickly, up to the minute, and having that very quick, fast, polished experience is what we're sort of trying to look for here. I'm not particularly going to be looking at the front end of this. This actually comes out as a website and a couple of apps. I'm going to ignore most of the details of those completely. What I want to look at is the pipeline we use to take content from the keyboards of all the journalists who are writing stuff for us and get it down onto these devices. I get that content through to people's browsers. If you want to actually take a look at this yourself, for a bit of context, bbc.co.uk/newsbeat has the website. There are Newsbeat apps for Android and iOS. This might help give you a bit of an idea for the overall structure of everything going on underneath, or inform you better on pop culture generally. And now we're just going to take a little bit of a look through the actual pages themselves too here. So the core main pages look something like this. We've got a series of tabs with a set of cards for all our different stories, all the different interesting news that's happened recently, all the important things going on in the world. We've also got popular tabs doing the same sort of thing from a different data source, a topics tab with a selection of interesting topics and characterized topics for every other thing under the sun. So we've got topics for Spotify, say, or technology, or North Korea, and so on and so on. And huge selections of pages with aggregations of these. And each of these links through to our articles, which look something like this. These are notable because they're relatively expensive pages to build. All our content comes from the existing BBC journalistic CMSs, various systems built around these. These are fairly old legacy systems. We have to make HTTP requests to go and talk to them. And we're trying to build a new, quite modern architecture for the BBC here. They're trying to move forwards, move things onto AWS particularly, rather than just running stuff on bare metal until now. So all these services are not co-located with us at all. They're a bit expensive and a bit unreliable to talk to in places. And we need to do a lot of communication with them to build a page like this. The actual structure of this page, we've got actual article content, so we have to go and talk to a system to get that content. We've then also got these interesting sidebars in various places of related stories and the most popular stories. So to build this, we're going to have to make another HTTP request to get the IDs of all the most popular stories, and then an HTTP request for each story, getting the actual headline and images for it, and then another request to the tagging system to get the relevant tags for each story. And then we're going to have to do the same for the related stories sidebar. And then if we go further down the article in the footer, we've got a selection of the latest stories. So we go and we hit another system where we get all of the IDs for that. And then we go and we make more requests to pull in all the extra content to put these together. All of these services are quite slow to talk to. A lot of these requests have to be sequential. We have to go to one place to get IDs, to get the next thing, to get the next thing. And we're trying to build really, really fast websites. We lose a lot of traffic if we go slower. Our users are people who really care about stuff feeling fast and feeling snappy. And this puts us in a slightly tricky position. We've then also got responsive versions of these sites for tablet and mobile, which are sort of similar with slightly different content in slightly different formats, and then also mobile apps, which obviously don't take HTML at all. They take JSON, and rather than composing the whole page together, they make requests for the various bits, and then they compose that and format that locally on the device. What I really want to hit home here is that we've got a lot of different things going on within any individual page. They're reasonably expensive. We've got thousands and thousands and thousands of these articles. This new Newsbeat site has to support all the new news that they're constantly publishing, but also all the previous news they've been publishing over many, many years. And we've got to be able to provide that in a whole range of different formats. And underneath, this isn't just some CRUD app where we can hit a database, join other things together and pull the data out. We have to go and talk to a series of slow, expensive and slightly unreliable back-end systems to pull all this stuff in. Hopefully that still doesn't sound too bad. It's a mostly static site. We're not really doing anything enormously clever here, but it does get a bit more complicated. We've got quite a lot of traffic. We are going to launch this. We have launched this, aiming to get 2 million daily users average coming through every day. For comparison, Slack hit that benchmark in about December. And this is what we're going to be trying to do out of the gate with a brand new system. This is non-trivial. There's some work required to do that. On top of that, this is a news site, which means it is incredibly spiky traffic. Sometimes Kanye West is going to tweet links to our news, and all of his millions of followers are going to suddenly flood through to our site. We have to be able to handle that, and not only handle that, but come back still with requests that are really, really fast. Traditionally, you just cache the hell out of this, so maybe that's fine, but also we have to be able to publish news very quickly. Not only new news here, we're going to have lots of interesting content coming out. We want to get that into people's hands very quickly, but also updates. If you are a journalist trying to get the scoop, to get your article out as quickly as possible, what you conventionally do is write a very short piece initially, and then over the following minutes and hours, update it as more information comes in, lengthen it out, and continually release updates to this stuff. We need to be able to get these into people's hands very, very quickly. We also have to think about redaction here. If at any point, as the BBC, we discover that we've published the wrong thing, we have to be able to correct that everywhere. And it's a pretty hard constraint. We have to be able to ensure that we have validated any cached versions of anything, anywhere, within a minute. For any bit of content, we have to be able to push stuff right the way through. And this means just caching our many, many thousands of articles very, very heavily to deal with all this traffic becomes a bit more problematic. We're then also building on some slightly legacy back-end services. So these services power all journalism in the BBC. This is the content management system that BBC journalists use. And if we hammer it with requests and take it down, we will take BBC News offline, which will be international news and very embarrassing. It's going to be bad for us as a contractor to the BBC. More practically, if we're building a system that has any chance it could do this, the BBC won't let us put it live. We have to be able to very convincingly ensure that we're never going to be hitting the back-end systems more than we want to. We're being quite careful with these, and we're handling them with a degree of respect. We've also finally got to make this quite reliable. This is a BBC project. They are big and high profile, and you want to build stuff that really, really works and stays up, even under these kind of constraints. We'd like to ensure that when back-end services are totally unavailable, we just keep serving the last good news we had available. We just continue delivering this news indefinitely. These reliability constraints are not absolutely hard. We don't have to guarantee really, really high levels of uptime, but we want to do our very best to ensure that as other stuff breaks, as we're dealing with these other systems, we still keep consistently serving the news. So, we've got to handle a lot of traffic that is going to be very, very spiky, building on sort of unstable foundations, and provide good, strong reliability and quickly publish stuff all on top of this. What I want to do with this is look at some ways you could build it wrong, essentially. I want to start with a whole bunch of different architectures and progressively build these up towards what we actually ended up with. This process is actually largely hypothetical. We designed most of this up front in discussions with the BBC, but what I really want to do is illustrate the various kind of thoughts and processes you have to go through as you're trying to make these kind of architecture work, as you're kind of trying to deal with these problems. I should note in advance, this is not Softwire's idea. We didn't magically come up with this and present it to them. Lots of these ideas are stuff the BBC have been working on in other smaller projects in small components here and there for quite some time. And what we're doing here is taking these ideas, we're building them bigger, and we're putting them into use for the first time to run a large, high-profile news site like this. Let's start with kind of the simplest approach. I suspect everybody here has built an application something like this. You take requests from the internet. You talk to some other services, slowly and ineffectively, to put together a response, and then you hand the response back. This is pretty simple. This is, for many cases, a reasonable way of building a web application, but this is not going to work for us for a whole bunch of reasons, but primarily because we're going to get a lot of traffic and everything's going to explode. If 2 million users turn up at the same time to get an article, we're going to make 2 million requests through to the back-end services, and they're going to burst into flames. And even if we could handle that, actually running our service is going to become quite expensive. And as people may be aware, the BBC at the moment are not in a great place to spend a lot of money on scaling services. What we'd like to be able to do is not run loads and loads and loads of these services, but do this more cheaply and not hammer the back-end services when we get lots and lots of heavy traffic. So we want to take this architecture and we want to do something to it that is going to allow us to handle more traffic, to more effectively deal with these problems. And the first pretty clear step is to stick a big cache in front of it. For an enormous number of cases, this puts you in a pretty good place. Requests come in, most of them serve the last stale content you've got straight out of your cache. Some of them are going to go through the cache, hit the service behind, and actually make requests to the content services, but far, far fewer. It's going to be a much rarer situation that we're going to have to deal with. We actually use Varnish for caching, which is very, very good, and we'll let you do all sorts of crazy stuff on top of this. You can serve up stale content from the cache indefinitely while you're getting errors from the back end. You can do asynchronous updates of cached content and all sorts of stuff with various bits of fiddling around. But even then, we have a fundamental problem with this, which is that all the actual hard work we're doing, all the dangerous, expensive bit, is still sometimes happening synchronously on requests. Critically, every time we get a cache miss, either because we've just published a story or because something's been evicted from our cache. And we can try and avoid that, but you're really fighting against the stream with caching systems once we dig into this. But at some point, we're going to get new content publishing. People are going to hit it, and the first people who make those requests are all going to be blocked waiting on the back-end systems. And even worse, if we have any problems with the back-end systems, if we start getting timeouts or actual errors, all of these people are going to see actual errors. There's nothing else really we can do. This is quite a common situation for news. We're going to publish an article, and it's going to suddenly go to being a big fancy banner at the top of a very high-profile website, and we're going to get lots of users coming through and seeing this kind of situation. And these 16 to 24-year-olds are all going to leave and read Facebook instead, and it's going to be very upsetting. And we'd really like instead to ensure that we don't have these kind of difficult, painful, expensive, risky operations happening synchronously on requests. So we're going to take this, and we want to stop doing that. We want an architecture that doesn't have that problem. At this point, you start seeing how we're going to split out different services, how we're going to let different structures power these kind of approaches. Because we just pulled it out. We'll start up another service. Now, we have a background service triggered by some kind of timer. Let's say for articles published today, we update them every minute. Articles published yesterday, we update them every hour, and so on. It just goes to the content services, grabs the content, and sticks it in some store, just raw as it is. But a store that is local to us is very, very dumb and simple, so it's not going to break. It's very quick to access. Think Amazon RDS, say. This is hypothetical, but that would be a reasonable approach. So we can pull content in like this, and all of a sudden now, cache misses that actually come through are much cheaper and much, much safer. Stuff that comes in here just goes to this very, very local, very cheap and easy data store, and we've essentially added an internal cache within our system, but built that into the structure itself. It's hard for things to go wrong now, and it's easy for things to become quick. This is pretty good. Still not great, critically, because how exactly we manage that back-end data loading, I've sort of washed over there because it doesn't really work. If you have articles that you want to get updates coming through to within a minute, you have to be updating those articles every single minute. And if you've got thousands and thousands of articles, that means you're going to be hammering your backend services with requests for these. And this is bad, and the BBC won't let us go live with this kind of thing because it will break their stuff. Alternatively, if you only update your content very infrequently, then you're going to be serving old news, and similarly, that isn't really acceptable. This same problem does exist with the cached version as well, and here at least we have a bit more control. With a cache, all we can change is the expiry time on the cache for how often content updates are going to get triggered, whereas here we've pulled it out from requests entirely. We can set whatever kind of time we like, but we still have to do time managed control here, and that is going to be limiting. So instead, we like to take this approach and come up with a new architecture. You're in a situation like this, and you want to find a way to not constantly repeat the data loading part of this, to take that expensive operation and only do it when it needs to happen. And for us, at least, the pretty clear approach to solve this is to flip that around. We hook SNS up to BBC Content Services, so Amazon's simple notification services, and we trigger notifications anytime a new bit of content is written. We hook that into a queue, and the data loader subscribes to a queue. It gets given a message saying Article 12 has been updated, and then it goes and gets all the data for Article 12 and puts it in the store. Notably, we make this change, and the front end is completely unaware of it. Because we've decoupled to this nice, totally dumb layer in the middle, we can make this change even at runtime if we'd like, and nobody would really know any different. But doing this allows us now to ensure that we only actually query for data when we really, really need to. This is much safer, this is much cheaper, and this is going to avoid us breaking things. We can still do better than this, so perhaps it's kind of annoying that we're unnecessarily re-rendering stuff. So we're pulling in the data for all of the 30-odd different bits of information we need to build an article page, say, but every time we actually get a cache miss for that article page, we're still going to go to our little data store and have to pull in all these 30 bits of data and work out how to glue them all together. And that's still messier than it could be. it would be nice if we could also get the same benefits that we're now getting for data loading for rendering as well, and only do that on demand. So this bit's very easy indeed, really. We take this, we want to do rendering only when it changes, so let's just do rendering only when stuff changes. Rather than having a service which goes to the content stores and just grabs the raw article data and putting it into a database, instead, when Article 12 changes, we go to all the different BBC content services we need to build an article. We render the whole HTML for that page, and we drop it into S3. Totally in advance, before anybody's even asked for this page. The instant a journalist presses save. Later, when requests come in, all we do is find that previously done HTML in S3 and serve it back to them. At this point, we get to a place where the performance characteristics of our front end become delightful. It doesn't do anything anymore. When requests come in, we really just look stuff up in S3 and send it back. It's difficult to break that. We're about as reliable as S3, really, which is a nice place to be, more or less. Certainly, it's within our levels of tolerance. And it's also very easy to make quick because you're not doing anything. We pull as much stuff off the synchronous path for requests as we can, and that makes requests really, really fast and really safe. We can still do better. So within this, we're re-rendering quite a lot of common elements quite often. If Article 12 changes, I want to re-render the whole article page, I'm going to have to work out what the most popular sidebar down the side is every single time, but often it won't have changed. More challengingly, if the most popular sidebar changes, I have to re-render every single article. That is quite a big problem. So we would like, instead, when content changes in the BBC services, to only update the parts of the page that are actually going to have changed, and to then just stick them together later. So we want to take this architecture. We want to think about ways where we can reduce those extra requests, where we can take the parts of a page apart and glue them back together later. Which, when you phrase it like that, sounds fairly easy. We take the parts of a page apart and we glue them together later. So here's where we start to actually get into the more micro level of the microservices. For each individual bit of a page, we have a renderer. What that renderer does is listen for updates that are relevant to that bit of the page and generate the HTML and or JSON for that bit and stick it into S3, but only for that subsection of the page. And then on the front end, we find content in S3 and we glue it together. We still drastically reduce the number of requests we're making through to the back end here, rather than pulling out 30 bits of content from the BBC content services. To build an article page now, we get, say, the 3 different sections of HTML and glue them together. So, for example, the front end here might go and get the body for the article that's been requested, and the most recent, most popular sidebar, and the most recent latest articles footer, and then just glues them together and serves them out. And if we get a notification saying that the most popular information has changed, we re-render the sidebar and the most popular page, and we put those into S3, but all the rest of the articles, all that other cached content in S3 is still valid. So we can keep sticking with that. Finally, there's one more change we want to make to this, which is that this service on the left here is still quite a big blob and is actually handling just more stuff than we'd really like. It's handling both the requests for the apps and the web, which is a bit messy, and ties the behavior of those two together. If we break how composition of pages work, if we do something stupid about how we build the HTML and everything starts crashing now, that'll take out the apps, but they don't care about HTML. It's frustrating that these are tied together. And similarly, if we want to scale these independently, we're in a tricky place. So we can take this and we can split that in half. And this, more or less, is the architecture we end up with for Newsbeat. This overall structure, and I'll dig into the components in a little more detail in a second, but this overall structure gives us a lot of really nice things, particularly most of the requirements that we initially looked for, things like reliability and maximizing performance and so on, come from the structure of it itself. We haven't really talked about implementation at all, but just from the structure of this, we're pretty sure that if the BBC content services go down, we're going to keep serving stale content because it would be difficult to write this in a way where you didn't get that. The structure itself is giving us the kind of benefits we're looking for. So we get all sorts of nice benefits, and critically, we don't have anything on the critical path, especially for the apps. They come in, they hit a broker, which just gets content from S3 and does nothing else, and then we serve it back. There's very little that can go wrong in this process, which makes the apps very reliable. So this is kind of the overall structure and the sort of ideas we were thinking about as we stepped through to build this. Let's talk about the actual components. So the renderers, for example, critically, and this is the kind of main thing I would focus on if you're trying to design these kind of architectures, critically they're very stupid. They do nearly nothing. They get a notification saying this article has changed, they get the content for that, they build a tiny bit of HTML, and they stick it in S3. And that is all they know of the world. That is everything they have ever heard of, and it's everything they care about, which makes it really easy to change them and change everything else, because they're not tied to the rest of the world, and makes them very easy to manage, to control, to understand. If you picked up our article renderer and looked at the code, you could make a pretty good guess of what was going on, because there's very little external interaction happening. This keeps things simple and gives us a lot of the benefits we're looking for. All that happens is you get a notification that something has changed, you get the content required from somewhere to produce your output, and you dump the result in S3. And this is a very flexible, powerful position to be in. And we've got lots and lots of these doing all sorts of stuff. So articles and the latest feed. We've then got topics rendering as each different topic changes. As a new Spotify story comes out, we re-render the topics page for Spotify or whatever. So on, we've got editorial content where people select different articles to be featured. We get a notification when that happens, and a renderer picks it up, renders that bit of the page, and dumps it out. Very, very simple renderers. And it's very easy to add more of these. It's a very flexible structure that lets us drops in new bits of page without really worrying about how it's going to affect anything else, because there are no interactions. They're very, very stupid. The broker is even dumber. It's really S3 lookup as a service. It takes a request saying, for example, I would like the body HTML for an article with ID 12. All it does is look up in S3 that HTML and serve it back. That's the whole thing. It is a simple lookup mechanism as a service. There's a little bit of detail to how we do the S3 stuff here to get certain levels of consistency. We've got some Dynamo bits around it, but there's nothing particularly clever going on, and all of that detail is in the broker. Nobody else knows about all this crazy magic. And the broker itself manages all of this on top, and this is all that happens if you're an app. You make a request to this through a cache, and it looks stuff up in S3 and serves it back. It's quick, nothing can go wrong, more or less. And then finally, we've got a composer on top of this. So this mostly consists of HTML templates for our pages. So the composer has a template that says, this is what an article page looks like. It's got the standard BBC header, and then the body of the article, and then the current most popular sidebar, and then the latest footer, and then our standard like copyright footer and this kind of thing. And it doesn't really specify any of the details of that. It just says, I want those bits of content for the URL that was requested, and it just passes those requests through to the broker, which does all the lookup and just hands it back. And we actually use a little bit of very short-lived Elasticache in between to take the edge off some of the repeated bits of this for many pages. This is really a templating engine as a service. It's a very dumb component that does very little. And as you start to move towards architectures trying to solve these problems, if you build these components like this, they become very easy to manage. The structure itself gives you a lot of the benefits you're looking for, and the specific services remain very easy to build, very easy to use, very easy to change. There's a minimum level of working parts here, moving parts here. Yes, okay, these are very easy to understand alone. The architecture is giving us the benefits we want independent of the implementation, which means it's hard to do the implementation wrong. And we're pushing content through this pipeline, really. And that's where a lot of this magic comes from, rather than having a system polling a back end, some kind of expiry where we occasionally check. Instead, when something changes, we immediately ping through to the notifications, which pings the queue, which pings the renderer, which drops into S3, which next time the cache expires, gets new content straight away. And we can just keep that cache very short-lived because it's very cheap to hit the broker quite often. Those cache misses are cheap and not too scary. Under the hood, the services are all written in Ruby. They're all running as auto-scaled EC2 instances because that's very, very easy here. These are all extremely stateless and very, very easy to scale up and down, and also very easy to monitor load on. We auto-scale on CPU for the broker and the composer, and just the queue size for the renderers. If we've got lots of articles being published now, we just spin up another 10 article renderers because there's a lot of stuff waiting on the queue, and all of a sudden stuff gets rendered way quicker. We use S3 and Dynamo for actual content lookup, SQS and SNS for notifications and queuing into the renderers, Elasticache to take the edge off some of the communication in between and avoid repeating the same requests too much, or actually paying the cost of repeating the same requests too much, and then CloudWatch for monitoring. One of the really nice things about the level of simplicity of the interactions here, just going through queuing systems and S3, is that they're very easy to monitor. If you want to know, whether the renderers are keeping up with their traffic, whether the renderers are struggling, you just look at the queue size for the article renderer. If it's empty, then the article renderer has been consistently picking stuff up and happily telling the queuing system that it handled it and it was correct. That's not perfect, but it immediately gives you a pretty good idea that things are probably working. And that kind of monitoring you basically get for free with Amazon. You pretty much just have to turn it on. So these kind of dumb components make it very easy to manage. The actual code underneath is written on top of a framework called Elephant that the BBC have now open sourced. So you can take a look at this yourself if you like, if you're writing Ruby. If you're not writing Ruby, the same kind of ideas are pretty applicable in any language. This kind of composer, broker, renderer structure works really well if you're trying to fight these problems. And you'd see interesting articles from people like The Guardian who are doing similar stuff, composing together components. Twitter has sort of similar problems where they're trying to do stuff in advance of requests. And as a pattern to solve these kind of requirements is remarkably effective. It's well worth checking out. And again, I should give credit to the BBC. They've been working and testing out these ideas for quite some time. And it's really exciting to actually see all this stuff come together nicely. To start wrapping up then, I want to look at some of the kind of key benefits that this system gives us. Critically, it's very, very quick because when requests come in, we don't do anything. And as a developer, that is the best place to be. You don't really want users to run your code. You just want them to get the right answer and go away. If you can make your front end as asynchronous as possible, if you can push your work so that you're doing it in advance, then there's less stuff to go wrong when requests fail. And if stuff does go wrong, you get notice in advance before any user has even noticed it, hopefully. It's much, much easier to keep it quick. It would be possible to build this architecture going quite slowly, but the way it's set up, it's quite difficult to do so. It's an architecture that makes it easy and encourages you as a developer to do stuff that's going to be quick, because you're not doing anything. This is also very robust. Again, stuff that fails simply doesn't really affect our front end. And that's particularly interesting because we're building this on tricky back-end systems, on systems that we can't really rely on to necessarily always get our data quickly. Nonetheless, we can provide a very, very quick and very reliable service on top of that. We actually had problems initially in our development environments before we'd set up monitoring because the renderers would go down, we'd totally break them, and the site keeps running. You just don't notice. For quite a long time, it's really, really easy to be developing stuff and not realize you've broken these other components because you can take down all the renderers. You can take down the entire content services. If we're thinking about the apps, you can also take down the composer. You can take down nearly everything, and the site just keeps running. It's very hard to kill. This is really interesting. It's quite hard to end up with systems that are quite this resilient to failure without having to actually build quite complicated implementations. Here the implementation is very simple, the structure is reasonably simple, but we get these really powerful properties very easily. The encapsulation is the kind of magic of microservices that comes over the top. If we were trying to build the same sort of thing as a monolith, it would be very difficult to really think through the same structure and ensure that we were guaranteeing modularity. It's easy to end up with a tangled mess, and microservices force you to actually deal with that. You have to be very clear about where stuff's happening, and by knowing that the renderers are totally running on a different box to the composer, we can be really, really confident that they're actually separated, that the composer actually will keep running if the renderers go down. We also get really nice effects from the very simple interactions between these. For example, we have to, when we put this live, we had to republish every Newsbeat article that has ever been written. They've been writing stuff for quite a while. They've got many thousands of articles, but these articles all still need to be available on the new site. That's a bit tricky because we render articles in advance. But in our case, actually, quite easy. The article renderer doesn't really know where its notifications come from, where the stuff on its queue comes from. So if we want to re-render every single article, we write a tiny script that gets the IDs of every article ever published and just slowly drops messages onto the queue with all its IDs. And from the point of view of the article renderer, it's as if everything had just been republished, and it goes and re-renders everything. And we only have to do this slowly to avoid burning out the back-end systems. But having these very simple queues as our interaction mechanisms makes it really easy to poke in at what's going on and actually change the behavior. Similarly, in the broker, we can serve up content that actually hasn't come from a renderer at all. So we have dynamic config for the apps that changes bits of behavior remotely. They query a server to ask exactly what they should do for various things. And we could build a renderer that rendered that content and put it in S3 and then go through the broker to get it, but that's a bit messy. So actually we just built a very simple tool which lets you just save a file into S3, pretty much. And the broker serves that like it does any other content in the world. The apps already know how to get that. All the rest of the system just keeps working, and we can just drop static content in there because the broker is so separate to everything else that's going on the other side of S3. Then, finally, the real magic here is that it's hard to do wrong, which, as a developer, is great, because I do things wrong all the time. It's easy within this to build implementations that actually work, because the implementations don't have to be very clever. It's lots of very small, dumb components, and the nice properties we're looking for, solving the requirements we start with, come from the structure itself. Come from small, dumb components clicked together. Just like this. It's sort of safe by default, and it encourages us constantly towards doing things in a quick way, in a reliable way, in a maintainable way. It's hard to do wrong. There are still a few downsides to this. I don't want to pretend everything is magic and roses. Critically, everything here has to be cacheable. You cannot have content on the site that you aren't prepared to keep cached in its current version on the site forever if no future updates come in. In our case, this isn't too bad, but there are a couple of places, notably every article at the top has a sort of relative published 1 hour ago kind of time, and you can't cache that forever. An hour from now, that will be wrong. So you have to be aware of these kind of problems and think about this if you're looking at this kind of architecture. What we actually do in our case is publish it both in the HTML and the JSON in fixed times, so published on date, or just in timestamps for the JSON, and then we format it client side. So in the apps, that's very easy and pretty standard. You push a timestamp through in the JSON, and then the apps render a nice, pretty bit of text from it. In the website, this means we publish static text saying published on date, and then we add attributes to the elements around that, and some JavaScript rewrites that into relative times. That bit's slightly messier, slightly awkward, well worth the other benefits we get here, but not perfect, and is something that could really catch you out if you have other areas of your system like this. Data migration is also an interesting problem here. If you think versioning APIs is hard, imagine if you can't change any of the data you've ever sent before. Like the fact that we're pre-rendering all this stuff, if we want to change the format of the article JSON we serve, we have to re-render every single article we've ever seen. This really could bite you. If you're in a situation where this kind of content is going to change frequently, you could get into quite big problems. People like Twitter have to actually deal with this at a quite hard level. They do the same kind of pre-rendering of content, but obviously there you're building a product that's going forward and changing quite a lot. You want to be able to change these structures, but it's potentially difficult to do so. You have to be aware of these kind of problems, and there are all sorts of approaches you can kind of come up with to deal with them, but it's not an easy thing to work with. In our case, this has been kind of fine. We haven't had a lot of data changes, but it is stuff that could really come and bite you. Finally, there's quite a lot of code sharing within these, and this is quite a contentious topic within microservice design. The particular bits that come up for us are in the renderers. They share a lot of logic for how they talk to the backend services, for example. They all talk, or many of them talk to the same backend services. They all need a same common understanding of the API. Similarly, they all need the same common understanding of what a card looks like on those feeds, for example. They all have the same output templates for those. So we need to be able to share logic between these. We do this with gems, with Ruby's package management. That works okay. It doesn't work well. The pain comes in here when, say, you want to change what a card looks like everywhere. So you change the actual package, and then you have to go and update the versions in every single other renderer. And if you forget one, which is very easy to do, then immediately you're going to start get some bits of the site that have the new version and some bits that don't have the new version. And stuff won't actually break. It'll be fine, but it'll look messy. And we had other bits where we added in Elasticache across all the requests to backend services, for example, again, and there it's really, really easy to not notice that you haven't updated one of them, and you get interesting, tricky problems. Some people would say that if you're building microservices like this, you shouldn't share any code whatsoever. You should just duplicate all of that logic everywhere. I think, certainly in this case, that is very wrong. You'll end up with enormous duplication. Big parts of the renderers particularly are shared in lots of ways, which is tricky. The other big option is to pull out more services and have a service that just templates individual cards, and another service that you talk to, which then talks to the content services behind it, and you don't have any library between you and your other service. And there's other stuff there, but you end up adding in lots of extra complexity, and there's definitely an interesting trade-off here. Perhaps you could stick with the package management approach and do mono repos instead, so that you don't have to think about updates and you've got a fixed version of everything. But again, that comes with pain, awkward, trickiness, so it's not great. I don't have an easy answer for this one. I'd be quite happy to chat about it with anybody else who does. That sounds very useful. Gems worked okay for us. It's a reasonable approach. It's not great, but it'll get you through. Okay, so that's everything I've got for you today. I think we might actually have a couple of minutes for questions, just about. Just to wrap up, I am Tim Perry and Pim Terry on Twitter, and I'll be sticking the slides out later if you want to go and have a look through. And I do work for Softwire, and we are available to hire in London and Bristol if you're interested in that. Thank you very much.